Welcome back. This is Mrs. Rubright, and this is Algebra 1 Honors. Today's lesson is on 5.4, Solving Special Systems. Alright, so our first example is solving special systems by graphing. Use the graph to solve each system of a linear equation. Okay, so x plus y equals 7. So you can do this using your x and y intercepts. So your x-intercept is when y is 0. So your x-intercept is at 7. Your y-intercept is when x is 0, and that's also going to be at 7. So I'm going to go to 7, and I'm going to go to 7, and I'm going to connect that line. Okay, so that's our first equation. Our second equation, we can do the x and y intercepts again. So your x-intercept is when y is 0, so that's going to be at 3. And the y-intercept is also at 3. So we go to 3, and we go to 3, and we connect that line. So we have these two lines. We can see that they are clearly parallel, right? We're going down 1, over 1, 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 down 1, over 1. They are parallel lines. Is there a point of intersection? No. They are parallel. Right? No, they're parallel. So if they're parallel, then they don't have any points in common. They don't have any points in common. Does this linear system have a solution? Use the graph to explain. No, it has no solution because there's no common points. All right, so let's look at the next one. Is there a point of intersection? Explain. All right, so for this one, you can graph it, right? Or instead of graphing this, what if I put them into y equals mx plus b to look at their slopes? Like, to me, my brain works off of slopes, right? So this would be y equals negative x plus 3. And this one up here would be 2y equals negative 2x plus 6. Divide by 2 everywhere. Y equals negative x plus 3. So they both have that slope of negative 1. Well, look at this. Isn't this the same equation here? And this one is just slightly different than here? Right? So they are both going to be a slope of negative 1. And they both have that y-intercept of 3. So you remember how this first equation had that y-intercept of 3? Well, now the second equation has the same slope with that same y-intercept. So what do you see here? Look at those two equations. What do you notice? Go to graph them. 3, down 1, over 1, down 1, over 1. 3, down 1, over 1, down 1, over 1. They are the same line. So is there a point of intersection? Yes. Every single point. So it has infinitely many solutions. Infinitely many solutions. They are the same line. Infinitely many solutions. They are the same line. Use the graph to identify two lines that represent a linear system with exactly one solution. Okay, so we could say, oh, they put a third line on here. Do you guys see this third line that they added onto here? So we could say that this line has one solution with this line, right? So 3x minus y equals 1 and x plus y equals 7 have one solution, right? Because they intersect each other in one spot. Because they only intersect in one point. They only have one point in common. If each equation in the system has two linear equations is represented by a different line when graphed, what is the greatest number of solutions the line can have? Explain your reasoning. All right, so in the equation, what is the greatest number of solutions a system can have? Explain your reasoning. Well, they either can have 1 point. If they intersect, it's at 1 point. If they intersect, it's at 1 point. If they are the same line, then it's infinitely many solutions. So they're either going to be no solution, one solution, or infinitely many. They're either parallel, no solution, right? Parallel, no solution. If they intersect, one solution. And if they're the same line, infinitely many solutions. Make sense? Those are your three options. All right, so identify the three possible number of solutions for a system of linear equations. I am always like, whatever the next thing that they're going to ask, I'm thinking about before they ask it, and I just wrote that on the previous page. So the three things is one solution if they intersect, no solution if they're parallel, infinitely many solutions for the same line. All right. Sorry for always being like one step ahead of this thing. I'm constantly doing it and then reading like, oh, that's what they want me to do next. All right, so solve the system of linear equations by substitution. All right, so they want us to take the first equation and they want us to solve for x. So in the first equation, x equals y minus 2. They want us to plug that into the second equation. So we're plugging this into the x in the second equation. We're distributing that negative. Negative y plus 2 plus y equals 4. Those are gone, and I get that 2 equals 4, which is not possible. So then that means that there's no solution. All right, because you can't have 2 equals 4. That's false. So no solution. What does it tell you about the solution? No solution. The system has no solution, which means that they are parallel. How is the solution represented algebraically when the system is solved using substitution? 2 equals 4 is false, so no solution. All right, let's graph them. So we have y equals x plus 4, and we have y equals, well, negative y equals negative x minus 2, which would be y equals x plus 2. Okay, so 2, up 1 over 1. That's one equation. And the other one is 4 with a slope of 1. So you do your y-intercept, and then up 1 over 1, up 1 over 1. Or down 1, negative 1, down 1, negative 1, right? Down 1 over 1. So, down, negative, down, negative, down, negative. Negative over negative is a positive, right? Or up 1 over 1, up 1 over 1, up 1 over 1. So you can see that these are clearly parallel. Solve the system by elimination. All right, so if we want something to eliminate, we can multiply the top one by negative 2. We would have negative 4x minus 2y equals 4. And we would have 4x plus 2y equals negative 4. All right, so when we do that, gone, gone, gone. Uh-oh, 0 equals 0. Is 0 equals 0 true? I bet this is the same line then, because it's true, right? If it was false, then they would be parallel, but this thing is true. They must be the same line. Look, if I put these into y equals mx plus b, y equals negative 2x minus 2. This one would be 2y equals negative 4x minus 4, divide by 2 everywhere. Y equals negative 2x minus 2. They are the same line. Infinitely many solutions. All right, so interpret the solution. So it's infinitely many. Same line. All right, well, if I want to graph them, we had y equals negative 2x minus 2. Y equals negative 2x minus 2. Down 2 over 1, down 2 over 1, down 2 over 1, or up to negative 1, up to negative 1. They are both the same line. Infinitely many solutions because they are both the same line. How is a solution represented algebraically with a linear system is solved using substitution. So you get 0 equals 0, which is true. So infinitely many solutions. Reflect. If x represents a variable and a and b represent constants such as a is not equal to b, interpret what each result means when solving a system of linear equations by substitution. So the system has one solution. The system has no solution. Right? If you get, like, think about numbers. This is saying, like, say a is 2. So this is saying, like, something like 2 equals 3. Not true. So no solution. This is saying, like, 2 equals 2. True. Infinitely many solutions. What did I just write? Hold on, I just got this wrong. Sorry, when I write fast, sometimes I skip letters. Okay. And this is saying, like, x equals 2, right? So then you plug back in to solve for y, right? Okay. In part 2 of example 2, why is it more efficient to solve and substitute for y than to solve and substitute for x? Why is it easier for y than x in example 2? Because the y's are already set up to eliminate. Wait, the x's are too. In example 2? How would they want to ask? In part B of example 2. Part B of example 2. This part. Okay. So, why is it easier for the y? Well, with your y's, you have y and 2y, so you would only have to multiply the top by negative 2. If you were doing the x's, you would multiply the top by negative 2. It doesn't make a difference. It's not. It doesn't make a difference, honestly. It's not. It doesn't make a difference. Okay. Give two possible solutions of the system in part 2 of example B. How are the solutions of the system related to one another? They must be referring to the wrong question because this one is the same line. I bet they're referring to a different example. Maybe they were referring to example 1. I don't know. That's a flawed question because it's not going to make a difference. You're going to get the same thing, so don't worry about that. Okay, let's do a practice problem. So I want you guys to try number 1. I want you to solve it by graphing. Your x-intercept is when y is 0. Your y-intercept is when x is 0. Number 1 has no solution. They are parallel. So to get my x-intercept, my y is 0, x is negative 8. My y-intercept, when x is 0, divide by 2 on both sides, y is negative 4. Down here, my x-intercept is when y is 0, so I get 4 divided by negative 2 is going to give me negative 2. And my y-intercept is when x is 0, divide by negative 4 on both sides, you get negative 1. Are you guys okay on finding the x and y-intercepts? So I go x, negative 8, y, negative 4, and I connect my dots. And then on the next one, I put negative 2 for my x-intercept and negative 1 for my y-intercept. I connected the dots. And then I want to just verify that they are indeed parallel. So I'm going down 1 over 2, down 1 over 2, right? So here, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. It definitely is both a slope of negative 1/2. Your slope on both of them is negative 1/2. So we know, yes, they are parallel. Therefore, there is no solution. There is nowhere that they cross each other. All right. So that is one by graphing. We can do one by substitution. So here we could solve for a variable and then plug back into the other one. We can add or subtract, so we can do elimination. This one's already perfectly set up for elimination. You would have, oops, gone. 0 equals negative 5. Is that true? False. No solution, right? False, no solution. So there are different ways to solve these. So I want you guys to do for homework page 295 and 296 in your workbook. We hope you guys enjoyed the lesson on 5-4, solving special systems. Please like and subscribe and have a fantastic day.